Okay, today we're going to continue talking about how to find zeros. We're still going to talk about the rational zeros test, but I'm going to give you a couple tricks that can help you eliminate some of your zeros. Okay? Now, on Monday, we are going to bring everything together. Okay, I'm going to give you an assignment that's going to correlate to these notes up here. On Monday, we're going to talk about how we find all of our zeros and what that means about our graph. We'll do all of it together. Okay? So the first thing that is going to help us is called Descartes' rule of signs. Okay? So first of all, just write, let f of x be a polynomial. Okay? Don't write this big long polynomial down. All that is saying is we have a polynomial to the nth degree. Okay? So f of x is a polynomial. Right? Where we have a constant term. Okay? That says our constant can't be 0. Right? So we're going to have two things we're going to look at. Okay? Descartes' rule of signs is going to tell us what we know about how many negative zeros we're going to have, how many positive zeros we're going to have. And these are obviously talking about real zeros. Okay? The number of positive real zeros is either equal to the number of variations in sign or less than by an even integer. I'm going to have you write it down, and then we're going to talk about what it means. Okay, so write down what you want to, and we'll dissect the meaning of that. Okay? The number of positive real zeros is either equal to the number of variations in sign or less than by an even integer. So first of all, what do you think it means by sign variation?
Like a positive or negative.
Right. Okay, so what we're going to do is we're going to look at the terms in our polynomial. Okay? So okay, our first term is positive, our second term is negative, our third term is negative. So since our first term is positive, our second term is negative, that is a sign change. Okay? And then when it goes from negative to negative, that is not a sign change. Okay? So from one term to the next, if your sign changes, that is a sign variation. Okay, so that's what you're going to count up. Now, it says that it is equal to that number or an even integer less. So basically that's saying if there are 5 changes in sign, you either have 5 positive zeros, 3 positive zeros, or 1 positive zero. You're going to count down by 2 until you can't count anymore. Okay? If there are 4 sign changes, then you're either going to have 4 positive real zeros or 2 or 0. Okay? Why would we count down by 2s? What did we talk about yesterday that came in 2s? Okay, if we have an imaginary 0, they come in pairs, don't they? They come in those conjugate pairs. So when we talk about our real zeros, okay, it's possible for a third degree polynomial that I could have 3 real zeros or I could have 1 real zero and 2 imaginary. Okay? So when we do this rule, we count down by 2s because we could have those imaginary zeros. Okay? Now, when we talk about negative real zeros, we have to count the sign variations for f of negative x. Okay, and then we do the same thing. It's either that number or 2 less, 2 less, 2 less. Okay. So we're going to go through an example. Basically, if you know that there's only going to be 1 positive zero, if you find it, don't try any other positive numbers. If you know that there are going to be no positive zeros, then don't try any, okay, when you have your list of possible rational zeros. Okay, this is going to weed out some of the numbers for us, okay? Or once we find one, it's going to weed some out, okay? So, we are going to describe the number of possible real zeros here. Okay? And we're actually probably going to go ahead and solve this. Okay? But we're going to use Descartes' rule of signs to help us determine how many positive, how many negative zeros will we have. Okay? So go ahead and write down the function. For our positive zeros, we need to count the number of sign changes. Our first term is positive. Our second term is negative. There's 1. And we go to a positive. That's 2. Positive to negative. That's 3. There are 3 sign changes. So there are going to be either 3 or 1. And then I can't subtract 2 anymore. So we say 3 or 1. Now we need to look at negative real zeros. All right, so we need to look at f of negative x. Right? So f of negative x, remember, that means we're just plugging negative x into our function. Okay? When is the sign? Yes.
So is it negative f of x or f of negative x? Because I thought on the other side you had written down.
It's f of negative x. Okay? What powers are not going to be affected by a negative inside? Even, right? If I have something squared or to the 4th, that negative is not going to matter, right? So f of negative x, this becomes negative 3x cubed. This stays as negative 5x squared. This becomes negative 6x, and that becomes negative 4. How many sign variations do we have? Every single term is negative, do you agree? All right? we're going to have 0 negative real zeros. Okay? So what does that mean for us? Okay? Our possible real zeros, if we use the rational zeros test, okay, our constant is 4, so we have factors of 4 over factors of our leading coefficient, which is 3. So we have 1, 1/3, 2, 2/3, 4, 4/3. Instead of 12 zeros to start testing through, we really only have 6 to test because I know none of these negative ones are going to work. Are they? Okay. It is nice, isn't it? Okay. So let's make our life easier. All right. So we had 3x cubed minus 5x squared plus 6x minus 4, right? What would you like to try first from that list of positive? I don't believe you. So we'll try 1. So we get 3. 3 times 1. We get negative 2, which gives us 4. Nice choice. Okay, so here is one of our positive real zeros. Either we're going to get 2 more from this, or what's the other option? Either these are going to be 2 positive real zeros or 2 imaginary zeros. Can we factor this? What do you think? That negative 2x in the middle is going to be really hard to get, isn't it? This isn't going to factor. So now what is our option? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is not going to take that much time. Okay? What do I have under my radical? We have 4 minus, which is negative, right? Okay. And what does radical negative 44 reduce down to? 2 radical 11i. Right? So we have 1/3 plus or minus radical 11 over 3i. We found 1 positive zero of 1 and 2 imaginary zeros right here. Okay. Just telling you it's a possibility. Okay? And that's why we have to count down by 2, because we could have these conjugate pairs of imaginary zeros. Okay? Descartes' rule of signs is very easy to use. It's not going to take very much time to evaluate that. Please use it to your benefit. Okay? I have one more rule that we can use. Okay? Okay? It's called an upper and a lower bound. Okay? So this says we have a polynomial with a positive leading coefficient, and we're going to use synthetic division. what we've been doing anyway, right? Okay, so we have a polynomial who has a positive leading coefficient, and we're dividing by x minus c. So that means we have c outside of our synthetic division, right? Okay. When I say an upper bound, what do you interpret that to be? Okay, maximum. Nothing can be higher, okay? So if we have an upper bound, that means everything needs to be lower than that, okay? So if we have a positive c outside of our synthetic division, we're testing a positive 0, and the last row, so what you get in the very last row underneath your synthetic division, if those are all positive or 0 numbers, then you have an upper bound. Don't try any zeros above that number. Okay, so if you try a positive c, you're testing a positive 0. If all of the numbers in that last row are positive or 0, 0 is fine, okay, then we have an upper bound. Don't try any zeros above that number. They're not going to work. That's what it means. Okay. We also have a rule for a lower bound. If you try a negative 0, a negative c, and the numbers in the last row alternate positive, negative, then c is a lower bound. Okay. Now a 0 you can use as a positive or negative. Okay, so if it follows the pattern, you can make 0 positive or negative to make that pattern. Okay. Okay. So we're going to work with a polynomial, and I want to show you what it looks like to be an upper bound. I want to show you what it looks like to be a lower bound. Are you ready? Yes, Mrs. Woman. All right, here's our function. Using the rational zeros test, let's list out our possible zeros. Okay. Factors of the constant are factors of the leading coefficient. Okay. So we have 1, 2, 1/2, 1/3, 1/6. 2 over 2 we already have. 2 over 3. 2 over 6 we already have. Okay. Now, just for effect here, I'm going to write these out in order. You ready? We have -2, -1, -2/3, -1/2, -1/3, -1/6, 1/6, 1/3, 1/2, 2/3, 1, and 2. Okay, those are our possible zeros. You're probably not going to do this, okay? But I just want to show you what it means when we have an upper bound and lower bound, okay? So, let's see. We have 6, -4, 3, -2. We like to try 1 first, correct? That's usually what we try first. Okay, 1 is positive, correct? Okay, let's do our synthetic division. We get 6, 2, 5, with a remainder of 3. First of all, 1 is not a 0. Second of all, we tried a positive 0. It didn't work. And you'll notice how the last row is all positive. That means this is an upper bound. Okay? Therefore, don't try anything above it. What?
I said that's helpful.
What is that off? Oh! This was a good thing. Okay. Alright? So, we've at least eliminated another number without doing any work. Okay? Okay, now I'm going to pick a -0 for you. We haven't done a fraction, we're going to do one.
We should do 1.
Oh, we're going to do -1/3. We bring down 6. What is 6 times -1/3? And when I add -4 and -2 together? And what is -6 times -1/3? And when we add this column, we get, okay. Now 5 times -1/3 is -5/3. It doesn't matter what we get here, but what kind of number is it going to be? Negative. It's not 0. So first of all, -1/3 isn't going to work for us. Second of all, we have a -0 that we tried, and this last row is alternating signs. Therefore, we consider this a lower bound, which means don't try anything below it. It's not going to work.
Yeah, that's true. Now they're all fractions. It's usually about the part.
Now, does anybody have a problem with me even trying a -1? Or a -0? You guys just let me do it. Using Descartes' rule of signs, how many -0s is this going to have? None. Nobody stopped me though.
Then why would you try it?
You didn't stop me. Okay. I wanted to show you what a lower bound looked like. Okay. That is why I tried it. Okay. But Descartes' rule of signs tells us there's not going to be a negative 0 anyway, so don't try. We're not going to solve the rest of this problem out. I wanted you to see what an upper bound and lower bound look like. Okay? What we are going to do is solve this one. This is our last example. But look at the instructions. We're finding zeros, and then we're writing our function as a product of linear factors. I will show you what that means. Are possible zeros. Factors of my constant are what? Okay. Over factors of our leading coefficients. So we have 1, 2, and 4 in the positive and negative variety. Okay. Descartes' rule of signs. How many sign changes do we have in f of x? 4. So we are going to have 4, 2, or 0 positive zeros. Right? We have the number of sign changes, or 2 less, until you can't do 2 less. Okay? F of negative x. Negative x to the 4th stays as positive. Negative 2, negative x cubed turns to positive. 5 times negative x squared stays. Minus 8 times negative x is positive. How many negative zeros will we have? No negative zeros. Okay? So we only have 3 to try. Woo-hoo. Which one would you like to try first?
2.
You want to try 2?
1 and 2.
Jenna's very insistent on 2. Does that work?
Oh, I must have read that part.
Yeah.
Oh, well,
Jeez,
just
Jenna.
kidding. It's not 2.
So let's try 1.
Hey, but now it's not 2. You're welcome.
Let's see. 1. I don't know why that took me a while. Yay! 1 to 0. Okay. That 3rd degree polynomial sure does look nice, doesn't it? Let's write it out. X cubed minus x squared plus 4x minus 4. Why am I saying that that looks nice? You can factor by grouping. That takes less time, doesn't it? It does. Me too. So, GCF of the first 2 terms, left over is x minus 1. GCF of the second 2 terms, left over is x minus 1. So we have x minus 1 as the greatest common factor. Left over is x squared plus 4. Okay? Store zeros. We found a 0 of 1 already. This gives us a 0 of 1. Okay, so it repeats. This gives us zeros of what? X squared plus 4 equals 0, means x squared is negative 4, which means x is what? Which is okay. Okay, there are your zeros. 1, 1, plus or minus 2i. Now, it asks for the product of linear factors. This is what we talked about yesterday. We had a degree of, how many factors should we have? 4. Okay, we have a 0 of x minus 1. What was its multiplicity? So we better have 2 of those factors. We have a 0 of 2i, and we have a 0 of negative 2i. There are our factors. Once you find the zeros, writing the factors is not a problem, is it? You once again have a short assignment. 8 problems. Over the weekend. There should not be a problem getting 8 problems done. Okay?